Hey, welcome to CNC Router Projects. In this episode, we'll be looking at the steps involved in making this traditional style wooden beer caddy. The entire unit was made out of pine, 3/4 inch thick for the bottom and the end pieces, and 3/8 inch thick for the horizontal slats on the sides, as well as the internal bottle divider. Some store-bought 1-inch diameter dowel was also used for the handle. Although the concept for the caddy isn't particularly complex, I still thought it might be helpful to show the individual components and how they fit together before proceeding to the drawing and toolpathing portion of the video. The bottom of the caddy is a rectangle that's been separated into 6 sections by a series of 3 1/4 inch deep grooves. These grooves are used to locate and stabilize the internal bottle divider. The bottle divider itself is composed of 3 separate pieces. Notches in the material, along with dog bone fillets, allow the pieces to slide together. The assembly then fits into the grooves on the bottom piece. The end pieces of the caddy join the bottom piece via a rabbet joint. There's also a groove with dog bone fillets that locks the longer portion of the bottle divider into place. Finally, there's a pocket that receives the dowel handle. The sides of the caddy are formed by 3 separate horizontal strips of wood, which are glued and were nailed to the sides of the end pieces. The bottom of the caddy can be graphically represented by 4 rectangles. But before it can be drawn, we need a few dimensions. I decided to divide the piece into 6 equal squares, each measuring 2 3/4 inches. Since the ends of the caddy overlap the bottom piece by 3/8 of an inch, that must also be taken into consideration. Finally, the thickness of the wood pieces comprising the bottle divider need to be factored in. The overall length of the bottom piece, then, is equal to the sum of all these sections. And the same holds true for the width. To draw the bottom, I'm first going to position a series of guidelines that correspond to those of the hand drawing. Instead of specifying all absolute values, I'm going to create guidelines based upon relative values. In VCarve Pro, I right-click on the guideline and under Create New Parallel Guides, select the Relative to Guides option. I then enter the position or offset value and click the Create New Guides button. Once this is complete, the rectangles can be drawn along the guidelines. The ones representing the grooves for the bottle divider are extended slightly beyond the edge of the main rectangle to ensure that they'll be pocketed completely. For the toolpathing, the grooves for the bottle divider were pocketed to a depth of 1/4 inch using a 1/4 inch downcut. The bottom was also cut out with a 1/4 inch downcut as an outside profile, using a depth slightly greater than the 3/4 inch thickness of the material. The layout of the bottom piece can also be used to draw the interlocking components of the bottle divider. The long portion of the bottle divider has a length equal to that of the bottom piece. For the height, I somewhat arbitrarily chose 3 inches. I'm going to draw a rectangle with those dimensions and assign it the same lower left-hand origin as the bottom piece. I'm then going to select that rectangle, along with the intersecting rectangles that represent the pocketed grooves in the bottom, and slide them off to the side for better visibility. The intersecting rectangles mark the location of notches that need to be made. These notches need to extend exactly halfway through the material height-wise. So I'm going to position another guideline at 1.5 inches and draw a straight line along it. Now I'm going to use the vector trim tool to remove the unwanted portions. Finally, I'm going to add some 1/16 inch radius dog bone fillets to the inside corners of the notches to ensure that they fit together properly. The process for drawing the short pieces of the bottle divider is essentially identical. This time, the rectangle equals the width of the bottom piece by 3 inches. The only toolpathing required for the bottle divider components is an outside profile to full depth using a 1/8 inch bit. The end pieces of the caddy are tapered rectangles. The width is equal to the width of the bottom piece, and for the height I chose 12 inches. The bottom 7-inch portion is a true rectangle. This measurement was determined by the height and spacing of the horizontal slats that form the sides of the caddy. The slats measure 1.5, 2.5, and 1.5 inches, with a 3/4 inch spacing in between. These measurements total the 7 inches. Above this point, a taper occurs and joins a 2.25 inch line segment that's positioned 12 inches from the bottom and centered from side to side. With the basic shape created, it's time to take a look at the joinery. The end piece connects to the bottom piece with a rabbet joint, so I want to pocket out an area with a height equal to the thickness of the bottom piece. I've oversized this rectangle slightly to ensure that the area is machined beyond the edges of the piece. This is pocketed to a depth of 3/8 of an inch using a 1/4 inch bit. Next is the groove that locks the long portion of the bottle divider into place. This needs to be equal to or slightly wider than the thickness of the divider and be the same height. It's centered from side to side and is recessed 1/4 inch below the top of the rabbet joint to account for the fact that the bottle divider sits in a 1/4 inch deep pocketed groove on the bottom piece. There are also 16th inch radius dog bone fillets in the upper corners. This is pocketed to a depth of 3/8 of an inch using a 1/8 inch bit. Finally, a 1 inch diameter circle represents the point of attachment for the dowel that serves as a handle. The circle is centered from side to side and positioned with its center 1.25 inches from the top. It gets pocketed to a depth of 3/8 of an inch using a 1/4 inch bit. To finish the caddy, I opted to use an amber shellac. I applied 2 to 3 coats, sanding the surface lightly in between. After the caddy was assembled, the shellac was allowed to dry for several days. Then, the easily accessible surfaces were rubbed out with paste wax, applied to superfine steel wool, and the excess wiped off with a soft cloth. This results in a very smooth surface with a nice sheen. In cases like this, where the finish is applied prior to assembly, I like to perform another test fit of the parts before the glue up. Sometimes the wood will have expanded or the finish will have accumulated in certain areas, causing problems with the fit. It's better to discover this before the parts are covered with adhesive. The first step I took was to apply glue to the grooves in the bottom piece and then insert the bottle divider assembly. Next, the joints of the end pieces along with the mating surfaces were glued up. Padded trigger clamps were used to ensure good contact between the parts while the glue dried. To attach the horizontal slats, I first sanded off shellac from the appropriate portion of the slat and its mating surface on the edge of the end piece. With the caddy on a flat, level surface, the bottom slats were glued, positioned, and held in place with padded trigger clamps. A pneumatic nailer would also work well for this purpose. The remaining slats were attached using the same method, except a 3/4 inch piece of material was placed in between in order to achieve proper spacing. Finally, I decided to attach a bottle opener to one end of the caddy. If you find these videos helpful and informative, and you happen to be in need of some of the tools or supplies used in these projects, please consider purchasing them from Amazon via the links on my associated website. Thanks.